Okay, this is topic 48, optimization problems. So on example 1, they're asking us to find the shortest distance from y squared is equal to 2x to the point 20. So what we do here is this is just the graph of what this would look like, y squared is equal to 2x. Alright, and I know to find the shortest distance, well, if I'm trying to find the shortest distance, I'm going to use the distance formula, right? Which is, this is just the definition of the distance formula. And then after that, what I'm doing is I'm plugging in 0.20 and to the x1 and y1. Okay, so now that's what I did. When I FOIL this, and when I square this, I get to this. Now, I want to have my distance formula in terms of x only. So therefore, I went ahead and substituted 2x into y squared. So remember that y squared is equal to 2x, so therefore I can replace this with 2x. And then after that I added the like terms. Alright, so far that's going to give me the distance, but think about it. This distance right here varies, right? The distance between 0.20 and any point on here is given by this. However, I'm trying to figure out the shortest distance. So what I can do, right, if I go to my calculator and if I go to y equal and if I graph this, right, so this is the equation. Notice that now distance is equal to this, or y1 is equal to that. If I look at this graph, right, I'm going to put it right here. If I look at this graph, every y coordinate on this graph represents a distance. Alright, it represents a distance between that point and that line. That's what every y coordinate represents on here. Alright, if we could use our calculator, all we had to do was look for the minimum point right here. Look for that point right here, and that would give us the x coordinate. Alright, and if that gives us the x coordinate, then I can also get the y coordinate by plugging it in here, and that will be it. That will be over. Alright, however, using calculus, what we're going to have to do is we're going to have to use some of the knowledge that we have. Alright, now I know from calculus that the tangent line, the slope of the tangent line at this point, because this is a minimum, the slope of the tangent line is 0. Alright, so if I know that, what I can do, assuming that I didn't have a calculator, is I can take the derivative of this function. Alright, so to take the derivative of that, well, I'm going to have to use a chain rule. Alright, so before I do that, I'm going to go ahead and rewrite this as x squared minus 2x plus 4 to the power of 1/2. And by the way, if I talk way too fast through this, just pause me, copy that down, and move on. Alright, so after that, what I'm going to have to do is that type of chain rule. Alright, so if you don't remember, the outer function would be the 1/2. The power to the 1/2, that is. The derivative of that would be 1/2 defined at the inner function to the power of negative 1/2. The inner part would be x squared minus 2x plus 4, and the derivative of that would be 2x minus 2. Alright, so one more time, remember the chain rule says that you take the derivative of the outer, the outer part is the 1/2 power, defined at the inner, times the derivative of the inner part, alright, which is this. Alright, so anyway, so the derivative of this would be, let's see, I'm going to write it like this, see if you can follow. You have 2x minus 2 over 2. Notice that this is to the negative 1/2, so I can put that on the bottom here, right? Over the square root of x squared minus 2x plus 4. So I'm skipping a few steps here, but hopefully you can follow. Now, if I do a little bit of simplification, just to make my life easier, I can factor a 2 out of the top. Because here in a minute I'm going to have to set my derivative equal to 0, and I'm only doing that because I know that that's where the minimum or the shortest distance is going to appear. Alright, that's going to give me the x coordinate where that happens. So now what I have to do, this is a simplified version of it, I'm going to have to set this equal to 0. Oops. That was already gone. So I'm going to have to set that equal to 0, and if I cross multiply, well, then I just get x, you can put this over 1 if you like and cross multiply. You get x minus 1 is equal to 0, which means that x is equal to 1. All right, now if we look at this graph again that I have, you can kind of tell that was going to happen, right? At 1, it looks like I have my minimum, at 1, it looks like I have my minimum right here, okay, which is where my, where the tangent line whose slope is 0 is located. All right, so now again, that gives me the coordinate where I have a minimum. All right, so now what I have to do to find the minimum distance, right, I'm going to write that over here. So I'm going to draw an arrow here. All right, all I have to do therefore is plug in that 1 into this formula. And this gives me my shortest distance, or my minimum distance, if you will. All right, so technically we're done with that problem. All right, that's it. Now, if I want to find out, let me think about this for a minute. Well, I guess that's the shortest distance. What else do I need here? Do I need anything else? Okay, so say that the problem is asking me what is the coordinate of that point. All right, so I want to find out. Now I know that this right here is 1. How do I figure out that y coordinate? Well, to figure that out, I can just plug this in into the original equation that was given to me. By that I mean I have y squared is equal to 2x. So I'm going to write here to find y coordinate of curve y squared is equal to 2x. Plug in x is equal to 1. Alright, so to figure that out, I can plug in a 1 into this, which will give me this, which if I take the square root, I get a plus or minus square root of 2. Right, and that would make sense because that distance between here and here probably should be the same distance as some point over here. Okay, so that's my answer for that. If they were asking me to find the point where we have the shortest distance, well, in this one I have to have 2 points. So let's say you have 1 square root of 2, and you have 1 negative square root of 2. So that would be the point where the shortest distance is located between the curve and 2, 0. Okay, let's see what else. Okay, so that's it for that. There's perhaps other ways to do it, but we can talk about it in class. Now in example 2, alright, this is kind of a similar problem as what we did in Algebra 2, but more complicated obviously. So we have a Texas Ranger that has 800 square miles rectangular plot of land, and he wishes to divide into 3 equal regions as pictured below. Alright, so what we're going to do here is we're going to call this whole distance x. Alright, so we're going to call this whole distance x, and I'm going to call this height y, or this width y. Okay, so we're going to try to find the dimensions so the rancher uses the least amount of fencing. Right, so I'm going to say that the fencing, because I don't really know anything other than these regions are equal. Or I'm going to call this fencing as equal to 2x, right? So I have 2x, which is that distance and that distance, plus the fencing that would be required to enclose this 3 areas, which would be 1, 2, 3, 4. And since the width right there is y, I'm going to call this 4y. All right, so this formula represents the fencing, the amount of fencing that it needs to be used. All right, so now the next thing that we need to do, just like the other one, I need to get this in terms into one variable. In this case, I'm going to try to figure this out in terms of x. All right, so to figure that out though, like I don't really have a whole lot of information, but what I do know is that he's got 800 square miles. All right, so that's an area. So I know that the area would be equal to x times y. And if I know the area is 800, then I can say that y is equal to 800 over x. And obviously this will take a little bit of thinking on your part. Like I didn't just come up with it just now. Like I did this problem ahead of time. So this is normally the part that would take a little bit of thinking. All right, so if you're wondering how did I get this, I had to sit down and figure out a relationship between this and that. Okay, which is, that's it right there. So now I'm going to substitute that y with 800 over x, like that. Okay, so now I'm going to simplify this a little more. So I have f is equal to 2x plus 3200 x to the negative 1, right? Or you can write this as 3200 over x, same thing. Okay, so before we go on, what's going to happen is I'm going to take a derivative and set it equal to 0, because remember, where my derivative is equal to 0, that means that I have a tangent line, all right, at which I could either have a maximum or a minimum, because the slope of the tangent line is equal to 0. So when I set my derivative equal to 0, I am essentially looking for my max or my min. In this case, I'm looking for my min because I want to look for the least amount of fencing. All right. So again, that's why I'm taking the derivative. All right. Don't lose sight of that. Where my derivative is equal to 0, I could possibly have a max or min. Okay. So now if I take the derivative of this with respect to x, I'm going to have 2 minus 3200 x to the negative 2, right? So that's my derivative. Now, I'm going to simplify this a little more. So this would be 3200 over x squared. Now I'm going to set that equal to 0, all right? And then now all I have to do is solve. So now, here's what I'm going to do. I'm going to add this to this side. So I'm going to have 2 is equal to 3200 x squared, which is equal to 0. I'm going to come over here because I want to write something on the bottom there. Okay, I'm going to cross multiply, so I get 2x squared is equal to 3200. So x squared is equal to 1600. Alright, and I'm going to take the square root. And I'm only going to take the positive because x is a distance, right? X actually represents the length, if you will, of this fence. So therefore, I'm only going to take the positive, alright, not the negative. Alright, so now that I have that, right, I'm going to grab this and plug it back into the original. Alright, so I'm going to plug this back into the original to figure out the rest. So let's see. If I have, oh wait, I don't really know how much fencing I have, so I can't do that. Normally I would plug this back into the original, but I don't have that because I don't know how much fencing I need yet. Or if I knew that I can probably finish. However, I don't have that, but what I do know is the area. Alright, so if I have the area, and I know the 40 is x, then I can say that if the area was 800, x was 40, and I want to figure out y, well, I can just divide both sides by 40, so y is 20. Right, so x is 40, and y is 20. So that's the requirement amount of fencing that will require the least. All right, so this is the minimum requirement of material that I need for the fence. Okay. So that's that for that. Really, that's problem over. And let's go ahead and go. Let me just show you the steps of what you're trying to do, right? So just to concise everything, to condense everything, excuse me. These are the steps that you're going to need to do in this type of problems, all right? You need to read the entire problem. Mainly, what are you given? Alright, so what are you given? Step 2 would be to draw and label a picture. And normally this makes your problem a whole lot easier. Number 3, I think sometimes this could be difficult, but it's definitely doable. You're going to set up a geometric formula or equation. Step number 4, you're going to substitute. Substitute or simplify to get one variable. Okay. And then you're going to take the derivative. Most importantly, you're going to take that derivative and then set it equal to 0. Because remember, when I set my derivative equal to 0, essentially what I'm looking for is my max or min, according to whatever problem I have. And after you figure out the first variable, alright, that's normally going to give you one of the variables, you're going to solve for the second variable. And normally all that requires is for you to plug it in back into the original, but sometimes you have to do a little bit more thinking, like I had to do in example 2, and just solve for it. Okay. Now this is definitely going to take some practice, so hopefully you have seen this video, and we're ready to go tomorrow with some problems.